Good morning, students. Let us see the topic asymptotic notations. First, to define what is asymptotic notations. Then, after why we use these notations. Okay, asymptotic notation is nothing. So, here to use some of mathematical symbols. That means O, omega, theta, little omega, little O. So these are the mathematical tools because asymptotic notation is completely based on the mathematical functions. To derive some derivations to substitute the value of each and every expressions, that means the polynomials. So asymptotic notations are basically based on the concept of mathematical functions. Okay, so asymptotic notation is nothing but what is that? Actually it is a symbols. Then why we use these notations are used to calculate the complexity of an algorithm. So we are already studying about what are the complexities of algorithms. So they are best case algorithm, worst case algorithm, and average case algorithms. Okay, best case is represent then to take minimum time take to complete execution of an algorithm is called the best case because it is take only very few time. So that is best case algorithm. Okay, then second one is worst case means maximum time take to complete execution of an algorithm. Then average case means then average time take to complete the execution of an algorithm. So these are the three complexities of an algorithm. Then after to study about frequency step or count step is used to calculate the complexity of an algorithm. Then after that asymptotic notation. So this is a very efficient notation used to calculation of an complexities. Okay, then first topic, big O notation. Okay, so big O notation gives an upper bound of an algorithm runtime. The notation used to calculate the maximum amount of time, that is worst case time complexity. Okay, so big O notation to specify the upper bound of an algorithm, algorithm. So that means to take maximum amount of time. Okay, upper bound. Just to listen, upper bound, then what is actually what is that? Because all instructions are arranged in data structure that may be used to stack. Upper bound means so linear, one by one. So the upper bound is maximum. Upper bound location is maximum time. So big O notation specifically used for the purpose of worst case algorithm. That means maximum amount of time take to complete the complete the algorithm. Okay, so that is worst case time complexity. Here to remember the main points, first one is law upper bound of an algorithm, second one is maximum amount of time, then third one worst case time complexity. These are the three main points noted from this big O notation. After to define the definition of big O notation. So the definition, let f of n and g of n be non-negative functions. So in this case here to use two main functions are there. F of n and g of n are the two negative functions. Then after to create the two positive constants, that is c and n naught. Okay, so the function f of n equal big O of g of n if there exist two positive constants c and n naught. So if you create that positive constants, if exist the positive constant of big O notation to meet the criteria, actually what is that criteria? The criteria is f of n is less than or equal to c g of n for all n is greater than n0. Okay, so this is the criteria. So two functions f of n and g of n, then two positive constants, that is c and n naught. So these are the two constants. Then after to meet this criteria, that what is that criteria? F of n is less than or equal to c g of n for all n is greater than n naught. So that is the criteria. Then after to define the graphical representation of big O notation, then here to specify the axis, x-axis and y-axis. X-axis can carry the function, that means n function. Then y-axis can carry in time complexity t. Then after to draw the function f of n and c g of n, then these two functions meet at a point. That point is called n naught. Okay, so actually what is the condition? F of n is less than Cg of n. So the condition is correct. Okay, f of n is less than Cg of n because Cg of n is the greatest value comparing with the f of n. So the diagram is also satisfies the criteria. Okay, then next to prove that one example about that big O notation. Big O of g of n equal f of n. There exist two positive constants. So already explained that what is that constant value c and n naught. Then if it is satisfied for all, 0 is less than equal to f of n is less than or equal to c g of n for all n greater than or equal to n0. Okay, then so this is the condition is satisfied through this example. Okay, prove that 3n plus 2 equal big O of n. So that is a example just to take the value of big O of n. Okay, then after to take otherwise consider the value of f of n equal 3n plus 2, then second function cg of n equal 4n. So this is the concept of just to consider the value of two functions. Okay, then next to satisfy through this table, first to take the value of n 1 2 3 like that, then after to substitute the value of f of n equal 3n plus 2, calculate using this n value, then c g of n is another function, then these values also calculating through this n value. Okay, so just 3n plus 2. Okay, first 3n plus 2, substitute the value of n. 3 into what is the value of n? 1. 3 into 1 plus 2 equal 5. Then after cg of n 4n. Okay, 4 into value of n equal 1. So substitute that value, 4 into 1 equal 4. Then next n equal 2. Then using the formula 3n plus 2. 3n plus 2, 3 into 2 plus 2 equal 8. Then after cg of n 4n, then 4 into n value 2, 4 into 2 equal 8. Then after to calculate the value of n3, n value is 3, then calculate the 3n plus 2 equal 11, after to calculate 4n equal 12. Okay, so then after to calculate these values, then comparing the condition, what is the condition? 3n plus 2 is less than or equal to 4n. So this is just to comparing of functions, two functions f of n and cg of n. So just listen here, then the f of n is less than, so these all values are less than or equal to then another function, that is c g of n, but the one condition is false. One condition is false, then the remaining two conditions are true. Okay, satisfy the criteria. So f of n equal big O of g of n because the function is satisfied. So we can write the function f of n equal big O of g of n. Okay, so 3n plus 2 equal big O of n. N is greater than or equal to 2 because n is n naught values condition. Two conditions are satisfied. Then what is the constant value is 4. So this is a big O notation. Okay, then after that big omega notation. Big omega notation is just reverse of big O notation because it is lower bound, because it take minimum time, so it is a best case algorithm. Okay, so big omega notation used in computer science to describe the performance of complexity of an algorithm. So these notations also calculate the complexity of an algorithm. Then what is the main function is given here? First one is lower bound of an algorithm, then second case used for the best case because it can take minimum time complete execution of an algorithm. So what is the graphical representation of big omega notation? Big omega notation, then x, as usual, x-axis can carry function and y-axis can carry t is a time. Okay, then after to draw the function cg of n and f of n, then after two functions meeting at a point that is represented as n naught. Okay, so here just to reverse, that means cg of function is less than f of n. So let us see, we write f of n equal omega, big omega of g of n. So that is a very important thing, function. So that means overall function we can write f of n. So that is represented as f of n. Then after that, what the overall function is represented as omega g of n, because this is a omega notation. So we can write f of n equal big omega of g of n. Then after to specify the same case from big O notation, that means the existing two positive constants that are n naught and c. So these are the two constants, and then it satisfies the condition. What is that? Big omega of g of n equal f of n. There exists positive constant c and n0, and to satisfy the condition 0 is less than or equal to cg of n is less than or equal to f of n for all n is greater than or equal to n0. So that is the condition. Okay, so cg of n is less than f of n. So the condition is satisfied. Okay, cg of n is less than f of n, because f of n function is maximum and cg of function is minimum value. So the condition is c of g n is less than or equal to f of n. The condition is satisfied. Okay, then after to prove one example, the same example is taking here, that is f of n equal omega, big omega of n, because the function we can write f of n equal big omega of n. So we can write the function is equal to big omega of n. Then after to consider the value f of n equal 3n plus 2 and cg of n equal 3n, after to that constant equal 3. Okay, constant value equal 3. So then after to substitute the value using through the table, the value of n equal 1, 2, 3 like that. Then after f of n equal then we can write 3n plus 2 is also given here. So that is missing. So the same table from big O notation is also given here. Then here isn't here cg of n. Okay, so equal 3n. From big O notations we can take a 4n, but here 3n. Okay, so after to calculate the value. Okay, so f of n 3n plus 2, that means 3 into 1 plus 2 equal 5. But just here the missing, because here the value is 4 is not there, here is given 3 is given here. Okay, then afterward 3. Okay, so 3n means 3 into 1 equal 3. So the value is 3 is given here. Okay, then after 8 is correct, 3n plus 2, that means 3 into 2 plus 2 is 8. Okay, here 3 into 3 9, 3 into 3 9. So the value is wrong here, the 9 is the correct answer. Then n value equal 3. Then after to calculate 3 into n. 3 into n means 9 plus 2 equal 11. So this is correct. This is correct. So the given here is changing the value. 3 into 3, 9 plus 3 into 3, 9. Then here 3 into 3, 9. So actually what is the value here? 3 into 3, 9. But here 2 into 3, 6 only. Yes. So here is mistake. 6. 3 into 2, 6. Okay. So here is the value is 3. 3 into 3, 9. So the value of CG equal 3, 6, 9. So if it is correct or not? Yes, correct answer. Okay, so just the table, I think I copied the same table from big O notation to big omega notation. That is a mistake is happening here, so you are correct it. Okay, so the value of f of n is 5, 8, 11 and the c of g value is 3, 6, 9. So that is correct. So just to comparing this value, c of g of n is less than f of n. So that is correct. So first 5. The value of 3 is less than 5, then 6, the value of 6 is less than 8, then value of 9 is less than 11. So the condition is satisfied. So the function of f of n equals cg of n. So we can write the function of f of n equal omega, big omega of n. So the condition is satisfied. Okay, so I stop here. The next topic, the remaining topics of theta notation, little o notation and little omega notations continue to the next video. So just to refer this video, then to understand the concept and prepare the notes also. Then if you have any doubt, then you can clear through the Google Meet tomorrow itself. Okay, thank you.